There we go. So we will be talking about workshop organizational structure and tools. All right. Now, what are these things that I'm speaking about here? Well, you will find out. Just stick around with me. Okay, so here is a little introduction. We'll be discussing and describing building tools and equipment that is used in a building project. Now, these are the tools, like it says here, that are used in any typical building project. So imagine you are building your house, a residential house, just a single story. There are certain tools that you will need to do the building, okay? And those are the kind of tools that we will be talking about. Okay, so that's our outcome for today, for right now, for this section, to learn about these tools. Like, what are these tools? What's this equipment? What's this plant? And remember, plant is not vegetation. When we talk of plant, we're speaking of really, we're just speaking of the material, the equipment, the tools that are required in a certain project. Okay, and also just remember, we're talking from the perspective of a contractor. Okay, assuming you are a contractor, these are the tools that you'll be using. Let's start with the small power plant. Okay, so these are small tools, they are handheld, but most handheld power tools are operated by electricity or by compressed air, either to rotate the tool or to drive it by percussion. Okay, so all that is saying is that we have two kinds of tools, that which require electricity, which means you plug them in an electricity plug to make sure that they operate. And the other ones by compressed air. Now these ones, it's usually you need like petrol to power the pneumonic, the pneumonic engine inside of it so that it can do its work. So really just think of it as it's either by electricity or by petrol or diesel, something like that. Okay, but here we refer to it as compressed air. Those are the ones we'll be looking at. So okay, there's that word over there, pneumonic. And I know it starts with a P, but the P is silent. So what you say when you pronounce it, really, you say pneumonic. Okay, so here is the pneumatic, which means air tools. Okay, pneumatic just means air, because if you think of pneumonia, you get pneumonia, really the sickness, if you inhale cold air. Now, I'm not an expert in any health thing. I'm just an engineer. So don't take my word for it. But what I know about pneumonia is that you get pneumonia if you're exposed to cold air. That's what I know. So just think of the same thing. For the purposes of this tools, just think of that. Pneumatic tools, they have to do with air. That's what I'm just trying to help you to remember. Okay. So these tools are usually used for heavier work, with the advantage that they won't burn out if a rotary tool stalls under the load. Okay, so it's just, this sentence is just saying that the pneumatic tools are usually reliable because they don't rely on electricity. Because remember here, we're comparing the pneumatic tools with the electric tools. So the pneumatic tools are actually more reliable than electric tools. But electrical driven tools are relatively quiet since there is no exhaust noise, and they can be used in confined spaces because there are no exhaust fumes. Now remember, I said the pneumatic tools, they use petrol to generate the engine so that it can operate. So that engine that is compressing the air and releasing it at the same time is very loud, as you can imagine. I mean, cars are very loud. If you can think of a car that has an engine, or a truck, let's think of a truck, it's more relevant. If you think of a truck, it has an engine, it puts diesel, it's very loud. And so it is with pneumatic tools too, that you put diesel in them and they are very loud. So the advantage of electrical tools is that they are not loud at all. And also they have no fumes, because remember, if you're gonna put diesel, that thing is going to have fumes for sure. But electrical driven tools, they have no such. So usually they are smaller, so they can be portable. And also that's why they can get into confined spaces, because they are portable, nicely portable, and they are relatively quiet compared to pneumatic tools. Because remember, we are really just comparing to pneumatic tools over here. All right. Okay. So here what we're trying to do here is just to compare the two differences between electrical hand tools and pneumatic equipment. As you can see from here, now on the electrical side, we can see that on the electrical side we get things like electrical drills, which is mostly used in construction. And what is it drilling? It's drilling holes so that you can put screws in. Okay, so that type of drill is what we're talking about. It's usually electrical. Angle grinders, that's if you're gonna grind wood, so you need these. Portable circular saw, all driven by electricity. Jig saw, to cut out patterns. All of these are electrical driven. Now, what's a jigsaw? I'm going to show it to you. You'll see it on the next slide. Sanders for cleaning wood and smoothing it, electrical driven. What are sanders? We'll talk about those. Routers, which are used to cut out moldings and recess for hinges. Okay, what are these? We will get to talk about them in detail on the next slide. I think it's just better seeing them so that you can know that this is a sander, this is a jigsaw. But all you have to know right now that all these tools are controlled with electricity. Now, when it comes to the pneumatic side, these tools need a supply of compressed air for their power source. Okay, so a jackhammer. What's a jackhammer? Well, it's commonly used in construction to break stuff, like break bricks, break stones, break ground, whatever. If there's something to break, well, probably going to use a jackhammer. It uses compressed air to operate. Jackhammer. And then we've got backfill temper, used to compact loose soil. Okay, so that compacting machine, I think I have a picture of it as well. It just compresses soil. It goes boom, 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 boom. That's how it goes. And then we got vibrators for consolidating wet concrete. So sometimes to consolidate is the same as compact, really. To compact wet concrete, you put these tubes inside that vibrate, and through that vibration, the material of concrete, because remember, concrete is just a mixture of cement, sand, and stone. So they need to, consolidate each other so that they get stronger and be compacted. So all of those tools, they use pneumatic air to as a power source to to operate. There we go. Pneumatic tools are generally very noisy. That's a given. That's one thing you should know, that all of these are noisy. As you can imagine, I mean, a jackhammer, it has to be noisy if it's going to break things. I mean, a temper has to be noisy. Okay. Let's look at this. What is this? These are examples of pneumatic and electrical hand tools. All these tools should be earthed unless they bear the two. Don't worry about that as much, because all it's talking about is the electrical tools. So as you can see over here, this red one over here is, let's go back to the slide, it's the drill. Okay, that first drill. And then let's look at this one here. See this blue one in the middle here? It's like that. If we go back here, we will see that it is a jigsaw. That's the jigsaw. It cuts out patterns. So to cut out patterns, you need a jigsaw. And then over here, what is this? That's a pneumatic tool. So that's a jackhammer. Okay, or it can be a backfill tamper, but it's normally a jackhammer. You've seen it. So you can see it puts in petrol over there, uses air then to be powered so that it can bounce up and down. Okay, and what's that there on the left, top left? Let's see. It's a grinder. There we go. Angle grinder. That's the grinder we're talking about there. And then what's this here? It's also an electric drill. I don't know why I have two of them. And this, I can't see it very clearly on the bottom left, bottom right, but I am going to assign it to be a, let's see, a router. A router. I don't know how to pronounce this word. A router. Usually I use a router, but you can't say a router. It's just that when you're on site, you're gonna have to say a router, because I think most people prefer the word router. Okay, so there we go. Now, now that we've spoken about tools, let's talk about a timber workshop. This is where timber products are made. So just think of something like a door. Think of a door being made. The processes that a door has to go through before it becomes an actual door, from being wood to becoming a door. All of this is done in a workshop, and it's called a timber workshop. So we're just going to speak about the machinery in a timber workshop. In this, the machinery required to make a door. Okay, so the uses of woodwork machines in a workshop where wooden doors are manufactured. First machines to be used will be a variety of circular saws. Okay, I want to move back and forth here. Circular saws. Okay, so if we look at this picture over here, this is a timber workshop. Okay, so you bring in the plank, or rather let's call it a plank. You bring in a plank, nice big plank, and there you're gonna use circular saws. If you look at the bottom left over here, you can see cross-cut saws. Those are when you bring in the big plank. So first you have to cut it through the long section. So you cut it through the long section. As you can see there, that's a long section. And then you use circular saws then to cut it diagonally. So it's like cutting this long piece into two pieces. Okay. So, but the theory starts on circular saws here. even the cross-cut saw can be a circular saw. But anyway, for the purposes of this, you start with circular saws and then you go cross-cut saws. As you can see here, it says cross-cut saws. Saw is used to cut the long pieces of the timber across the grain to a wanted length. So you can start with a circular saw where you cut diagonally, and then from cutting diagonally, then you can cut along the long piece. I think what you must know is that you use a cross-cut saw to cut along the long piece, and then across the diagonal using circular saw. So you can start with either or of these processes. It's just that in the picture, it started with the cross-cut. Okay, so this is the first step. Either you start with circular or cross-cut, but you do both. And then the second step is to cut a shorter and workable length along the grain into suitable widths with the rip saw. So now you will use the rip saw. Let's go back. Okay, so here it says from circular saw you go to the thicknesser. A thicknesser, now you have cut the door along the diagonal and you've cut it along its long section. Now you need to deal with how thick the door is. So that's the thicknesser we're talking about there. So you use a thicknesser to cut it along that section to make sure it's the right thickness. And then the planer, surface planing machine, produces adjacent smooth sides of the timber. Now, a planer is really, it's like if you can think of a sandpaper. It's a machine with a sandpaper. No, it's not the machine. That's a sander, the one with the sandpaper. A planer is the one, it does a similar job to a sander, only except it has something, let's call it a knife underneath, so that it cuts smoothly on top of the the door. So it cuts smoothly with that knife so that you get a nice smooth finish. Okay, and then finally the other two sides are cut according to wanted sizes by feeding the timber twice through the thickness. Okay, so you can further make thickness smoother. Usually, you can use a sander to do that. Now, the sander, it has a sandpaper that keeps rolling so that it makes it even more smoother. Okay, the tongues and grooves which are necessary to join the battens are best cut with a spindle molder, but great care should be taken. Okay, so a spindle modeler, if tongues and grooves, these are just if you want to, decorate your doors, or then you do certain patterns, you cut them deeply, you cut shapes through the door to make it look nicer. So you would use a spindle modeler, okay, to do that. And then to make holes for screws, the pedestal drill, it's just a normal drill. It's just in a workshop, they press a pedestal on the floor. A pedestal is like, when you're driving a car, there are pedestals for, there's a pedestal for speeding it up, a pedestal for stopping it. If it's an automatic car, then there's a third one. If it's a manual car, to change gears with. But here, this pedestal, so it's a similar thing, but here, this pedestal is to operate the drill, and then off with a sander or belt sander. Remember, sander is just a sandpaper that's put in the machine, and then it just rolls and sands. That's why they call it, it's shaped like a belt. It's just like when you put a belt on yourself, just imagine a belt moving now. That's what a center does. Okay. Let us move on. So here we go. Start. This is phase 1, cross-cut saw and a circular saw. Phase 2, thicknesser. Phase 3, overhead planer. Remember, planer, I said, makes it even smoother using a knife at the bottom. But so you either you take it there and then that's it, or and then it can go through a setting out bench where you're going to set it out to decorate it more. So this is the overhead planner is where a simple door ends. But if you want to do more patterns, then it goes to a setting out bench. From the bench, it goes to a bandsaw and to a spindle molder. So these two are just to make the necessary decorations that you would require for this particular door to make it look prettier. And then you take it to the tenderer, belt sander. These are just to smooth them out, so you can smooth it out on the edges, tenderer, or use a belt sander to smooth it out then all around on the door, and that's it. So this is a typical workshop, but added things to the workshop is that you need a tool room where you store your tools, and you need a foreman's office where with a glass window so that he can see what's going on the shop, and the foreman's office must be on the top floor so that it will be easy to monitor what's going on. Okay, and then lastly, you'll have a joinery workshop. Now that's where in your door now you want to put the hinges, you can just join things, or further decorations that you need to actually paste on the door and paint it and stuff like that. Okay, but this is a typical timber workshop. Okay, let us move on. Now, this is a flow chart of activities in a joinery workshop. It's the same thing. Just that workshop. This is just putting more details to it. Things that are in that workshop. So if you can think of a joinery workshop, remember here, I said you have a joinery workshop here. That's where you do further things to the to the door. So there, from storage, you can cut it further through the sizes by cutting an exact size or cutting the joints and molds. It's up to you. That's where now you do custom works on the shop, because sometimes you might find that customer comes and says, I want a custom door that is much smaller than the standard size, so you need to cut it further, or they say I want it like this, so you need to mold it further. And then from there it goes to the storage, and then the finishes either finishes are things like painting it. So you paint it or assemble the patterns that they wanted, the extra stuff they wanted on the door, and then dispatch. But here, let's look back. When you are cutting it through the size, you use tools to cut it. And what happens is that as you cut it, you need a sawdust extraction, because sawdust comes out. Now, sawdust is just the little furnishings that are coming out of the wood as you cut it, and you need an extractor to extract them. And then as you cut them further then and mold them, you need use some ablution, which is just these tools that mold and extract further. And then here, when you're doing your finishes, then you need extra supervision to do finishes. And as you do them, just think of painting. Paint comes with fumes. So you need a fume extractor. So you need to extract the fumes out. Okay, now you need things like first aid kit, supervision to make sure if anyone gets hurt, then there is sufficient things to help that person. Okay, so let's just talk briefly about how to arrange machines in a wood workshop. Make a proportional sketch of the space available, record the names of the machines required, then transfer the names into the correct. I think this is just talking about what I was trying to say here is that make sure that you plan it properly, that you put it down on paper so that you can transfer on paper to site what is on paper. So make sure that you plan it properly, have enough working space between machines, so that it will be easy to navigate and walk around and through them. It must be done in a way to remove broken machines and install new ones. This is just a maintenance plan. This is just talking about you should have a maintenance plan, and there should be enough space to maintain the machines and replace them if they break down with new ones. Okay. Large storage areas must be allowed at the entrance. So this is just talking about you should have storage areas, and the storage areas, it makes sense for them to be near the entrances, because just think about it. You're moving from the workshop to the joinery shop. So as you move and you enter the entrance of the joinery shop, you really need to have a storage facility next to the entrance. It just makes logical sense. Supervision should easily overlook machines. Now, this is just talking about that the office must be at a higher level. It must be high enough to see what's going on in the workshop to supervise easier. And then attention is to be paid to safety regulations. Safety is very, very, very important when it comes to any site. Safety first is what is said. Safety first, because the opposite of that, people get injured, and that's not a nice place to be in, because if someone gets injured, you're opening up yourself to lawsuits, you're opening up yourself to time taken from being productive. It could cost you more. So really, really just try avoid that by making sure that you pay attention to safety regulations. Okay, so now these are just some few differences between a construction site and a workshop. Here we go. Under a construction site, work is done in an open air space. So here it's done outside, but in a workshop, it's done under a shelter. Okay. Now, during bad weather on a construction site, work has to stop, because if it's raining, you have to stop work. But in a workshop, whether it rains or it's cold or whatever, work still continues. Okay. Rain results in workers sitting idle, because productivity is not going to happen if it's raining on site. But in a workshop, doesn't matter whether rain or sunshine, work continues. So productivity is higher in a workshop. Construction sites projects differ from one another, and this can make the work very interesting. But in a workshop, it's repetitive, so it's much more boring in a workshop, if I'm to use a strong word. It's boring in a workshop because it's repetitive, but on a construction site, it's more exciting because, you know, there's many things happening and it's not necessarily repetitive. Construction work is very dangerous in a construction site, which is outside. But in a workshop, you know, the danger is really controlled because there's more safety regulations being observed there. And then building firms usually operate in various regions, and therefore they have to comply with different local authorities and regulators. So there's more regulation as well from authorities in a construction site than there is in a workshop. Like, think of in a workshop, you just need safety regulations, but in a construction site, there's lots to comply with, such as does the drawings conform to the standards of that construction site? You know, there's regulations in terms of the type of soil that's there. So there's a lot going on site that needs regulations and, you know, standards. Okay, I think this is just more information. You can read through it if you are really interested in it. But what we've spoken about is enough for your test purposes and exam purposes. I think we are going to stop right there. That is the end of our presentation. Well, that's it from me. Thank you so much.